All right, I think we will begin.
Okay.
I'm going to first introduce you, Dr. Nyarko. Thank you very much for joining me today. Dr. Kofi Nyarko is a tenured professor in the Department of Electrical and Computer Engineering at Morgan State University and the founding director of CEAMLS, a multidisciplinary research hub committed to advancing responsible and inclusive AI development. He also directs the Data Engineering and Predictive Analytics Research Lab, where his research spans computer vision, neurosymbolic machine learning, multimodal AI, and generative models, with work that bridges fundamental research and real world application, including the use of AI in unmanned aerial and ground systems for remote sensing, autonomous navigation, infrastructure monitoring, and traffic coordination. Dr. Nyarko earned his BS, MS, and Doctor of Engineering, degrees in electrical and computer engineering from Morgan State University, and is the recipient of the 2020 U.S. Black Engineer HBCU STEM Innovation Award, honoring his contributions to STEM innovation and institutional development. As a member of the Maryland Responsible AI Council, he plays an active role in state level AI strategy, advising on public sector AI deployment and data governance, while continuing to serve as a mentor and advocate in creating pathways for young scholars in AI and data science. We are extremely happy to have him on Transportation Talks today, so I extend my gratitude again to him for joining us. Um, Dr. Nyarko, I want to just kind of set the table here and have you describe a little bit about your research related to artificial intelligence and related systems. What early experiences and observations did you have about these emerging technologies and their applications in transportation and mobility that got you thinking about their application more broadly, but also in particular with respect to safety and accountability?
Thank you for having me, Joe. It's great to be here. This is an area, when I say this, I mean AI is an area that I have been familiar with for a long time. And this is in the days prior to AI being a buzzword thrown around for everything. Back then it was machine learning. But my research in general spans computer vision, which has a basis in machine learning as one of its methods of implementation, in human AI interaction, autonomous systems, particularly ones across domains like transportation and assistive technologies. If I look at like a through line through all of the different domains that my research touches, it's really on like the realization that technical excellence does not guarantee equitable or safe outcomes. I remember one of the reasons why I suggested forming the Center for Equitable AI and Machine Learning Systems in the first place was an early experience I had with vision systems, vision models, which were designed simply to do facial recognition. I had a project. It was a fairly low stakes kind of a project where we're trying to do automatic analytics in the classroom by identifying students and their activities within the classroom, like their presence and absence. And it was just so interesting and so stark that the model didn't tend to do well on people with darker skin tones. And the reason why I thought it was startling was it wasn't a very hard problem to solve, at least from my perspective with classical computer vision. It got a little bit trickier with neural networks, only in the sense of you have to have a very diverse body of faces to train on. And that was really the key to making sure it was equitable. But it was just kind of crazy to me that those who released the models didn't, I don't know if it was they didn't care. They didn't take the time to ensure that it worked well across a diverse group of individuals. And so then I just became more interested in algorithmic bias and how technology itself could be the thing that exacerbates inequality in society. It, Essentially, that's how I came here.
Absolutely.
um, but yeah, so another a quick example is just looking at our recent project, the Urban Flow wheelchair. It's fascinating because when you look at implementing any autonomous system, you will come across the stark reality that what works in the lab sometimes falls apart in the real world just because of the complexity of the real world. Crowded airports, lighting that is inconsistent across the board. If we're doing something like trying to interact with the public and we're using human gesture as a method of control, that gets incredibly difficult just because of the way we are not very consistent with how we do things like gesture. So the real world just acts so much complexity that if you don't design your systems properly, it's basically set up to fail because you're not considering all of these possibilities and these edge cases and these different demographics you may have to work with. So, yeah, those kind of experiences shaped my belief that safety and accountability is something you design from the get-go, from the beginning. You don't just slap it on at the end. And this just means that you need more rigorous validation in real world conditions, just to make sure that you're doing things like benchmarking properly and understanding where all of the issues are within your models that you need to address for correction. But yeah, that's kind of where I currently am with my research and my approach to doing things.
Hmm. You touched on it a little bit just then, but I'm wondering if you think of this relationship between having robust capabilities of AI systems and our responsibility as engineers to protect individuals and groups. Is that necessarily a trade-off? Can you have your cake and eat it too? And when thinking about this relationship, are analogies to large language models useful here? Not necessarily with existential risk, but the way people talk about both bias and interpretability and things like that. So let's lean into the buzzword just for a little bit, if you wouldn't mind, and tell me about how you think about this relationship between capabilities and risk.
Yeah, so I think the balance lies in recognizing that robustness without constraints can be dangerous. You can't optimize strictly for a metric like accuracy or a F1 score or just some raw performance number without thinking of the other side of the equation at what cost, right? So there's always going to be some level of constraint you want to put on your design going forward. So in practice, we want to treat system capability and guardrails as co-evolving elements. It's not that you just focus on capabilities. At the very end, you slap on guardrails and everything is good. They must evolve together. So when I look at the analogy of LLM, I think it's actually a very good one. The more fluent and general purpose a model becomes, typically the more difficult it is to predict its edge behaviors. The really capable models, the ones that are being developed with hundreds and hundreds of billions of parameters, you can see that their capabilities are getting astounding. But because they're getting so astounding, it's also interesting that you get into this emergent behavior phenomenon where the model starts doing things you literally did not predict or expect it to do because it's so complex. That's just the nature of how things develop. So you have to kind of think of these things as going in tandem. As I'm building more complex systems, I am also co-evolving the methods to constrain these systems to behaviors that I wanted and not harmful, right? Um, if I look at some of the projects that we have going on within the center and within my research lab, there's kind of like an underpinning for it. For example, we have this, I think we're going to talk about this later on. We have a project called Trust Watch. And the purpose of Trust Watch is to take a look at models that are currently actively out there right now. These could be cloud-based models or models that are open source and hosted on-prem. These models are being used to drive everything currently in industry that you can think of. It could be autonomous systems, sure, but it could be like a point of sale service. You go to Wendy's, you talk to a AI to order your food. Sometimes some of these models are the models you're interacting with on the back end to get things done. But there's no place that when people come across incidents where some of these models are doing something egregiously wrong, like they are performing in ways that are unexpected, like the emergent behavior I've talked about before, or just unfair. There's no place to catalog this and then to look at how this is evolving over time. If these companies are really addressing the issues that these models are facing. So TrustWatch was designed to be this crowdsourced platform to just allow you to be able to report these issues with these models, but then also do automated testing for some of them and try and find their edge cases, try and poke and prod and see where they fall apart, because that helps in how they're integrated into systems and the guardrails placed around those systems.
Well, let's linger on those systems a little bit then, or those platforms, I should say. What does it look like from a consumer or a data collector who's using these systems as they interact with either an LLM, a system at Wendy's, or another customer service system? And how does it look like from the analyst perspective? Tell us a little bit about both ends of the system.
Well, yeah, from the consumer perspective, you hope everything goes right. And what it looks like, excuse me, it's like they are communicating with another human being in a natural way, and the responses they're getting are accurate, no hallucinations, no sense of being treated unfairly in any way or being presented with stereotypical responses or things that may denigrate or offend that particular population. That's like the hopeful thing, right? But technology, really tends towards the ideal. There's always something that goes wrong. And so, what may be the reality is that the interaction may assume things about the end user that the end user thinks, well, that's not true. That's offensive. Or may provide that end user with information that is just patently false. And hopefully the user has the discernment to be able to say, that doesn't sound right. Let me just go and verify this and let me check. But a lot of times, because they sound so authoritative, they sound like they are giving you factual information. Users don't question it. They just take it and walk away, and sometimes the information is wrong. The example is when Gemini came out, the first few months, it was advising people, to eat rocks and to put glue on pizza. And it was incredibly bad, right? And but it was so ridiculous what it was saying that everyone knew this was false information. The more dangerous, I guess, parts of the story are when it's not that obvious. When it's just telling you that, oh, a particular food is safe for you, even though you're diabetic, and it's not. It could be something as simple as that, but that could have some serious consequences. They fixed it, they pulled the model back, they did some more training, and I think it's better than it was before. But from the end user, that's the kind of interaction that you tend to get. And you always have to have this critical lens of, am I being fed the right information? Should I double check this information? Should I look at my different sources? Or is the reason why it's suggesting this to me because it's making an assumption of who I am based on its training data? And this is not accurate to who I am personally. On the back end, on the analyst side, hopefully what is happening is a process of continuous development and evaluation. They call this, test evaluation, verification, and validation. There's this whole process that goes into launching models. And it's not just I've trained it, it's out there, it's doing things, but it's how is it doing things? What are my automated checks that I have built into the system to just evaluate its performance and to see if this model drift, if it's doing something really wrong? And I hope, you hope on the back end, these systems have been implemented in such a way that it's a human being who is doing these evaluations or monitoring the results of the evaluations and deciding that, yeah, we got to pull this one back. Or yeah, we have to update our guardrails into this system or some other way to redress the fact that it's going astray, you hope. But not all companies are that diligent about it.
Certainly, they exist on a spectrum, and it is indeed the confidence with which these systems can respond that can make them a little bit unnerving. And one thing I would encourage anybody who's curious about these systems to do, just based on my own personal experience, is to really prod it about things that you know a lot about, you know,
Absolutely.
things that you know a lot about, and that there are ample resources for them to pull from. You know
Hmm.
what the inside of your house looks like, but it doesn't. But if you know a lot about, say, World War II or something like that, then that would be a perfect example,
Hmm.
just to understand the limitations. With respect to TrustWatch, however, the idea is that you are creating a crowdsourced repository of systems when they do fail. And I assume you're seeing probably some sort of broad-based patterns about when and how these systems fail, not only with respect to LLMs, but with AI programs deployed more broadly.
Yes. Now, I would caution you that this is a very young project. We
Hmm.
started off calling it Bias Watch. It went through a few update cycles, and we ended up at Trust Watch because it was more representative of the broader tools that it provides
Hmm.
to the end user. But in essence, Trust Watch, once Bias Watch, what it does is it allows users to flag outputs that they perceive to be biased, in addition to aggregating subjective trust ratings based on how users interpret their responses from various AI models in different contexts. These platforms, they operate kind of like a lightweight feedback mechanism that's layered on top of AI services, as capturing like not just what the model does, but how people feel about what it does. One surprising pattern so far, like I said, it's a bit nascent, but one surprising pattern so far is just how often perceived bias was tied not to factual inaccuracies, but the tone and the framing, and especially if it's the questions related to culture and identity. It's really a nuanced thing to understand an individual's culture. And sometimes these models just haven't picked that nuance very well. And a lot of times it's just really what they've been exposed to. We just be honest about it. They haven't learned context appropriately because they haven't been exposed to it appropriately. But that mismatch can cause a situation where people really perceive there to be a significant bias in the response given. Um, if you dig a little bit deeper, you can kind of get around some of these perceived biases just through prompting differently, like prompt engineering. You give it a different type of prompt, you get a very different response, and it's the same model. So it's kind of tricky delineating what is factual inequity or factual bias, factual hallucinations versus perceived bias or perceived inaccuracies. But I think it can be addressed through really uh, having the models give a better understanding of the context in which information is asked, and then taking into consideration who is asking the question, which are very tricky things to get right. Um, I would say, though, if models have explainability built into them appropriately, then this kind of alleviates this to a certain degree because that explainability would include narrative context. It wouldn't just be about numerical transparency. It would be like, given the following assumptions, or given this of what I know about you, or this situation, here's what seems to be the most appropriate thing. They're giving it more context in its output, which is very, very helpful.
Absolutely. And you see a little bit of this in the extended thinking functions of current models, especially if you use, say, I think Anthropic's models, Claude, are certainly very good at this. To a lesser extent,
Yeah,
ChatGPT and Gemini, they're getting better. Um, and yet, even when humans are dealing with these nuanced ideas about culture and identity, they make mistakes too.
they do.
So, as a researcher, what metrics are you looking for, or systems by which we can evaluate whether or not these faults exist within the system, or not
Yeah.
just LLMs, but these systems more broadly?
Well, you have to have a very layered approach, in my opinion. So it's not just like one particular technique or one particular fairness metric. Is you layer things like disparity across protected attributes with measures like disparate impact ratios and equal opportunity difference. But beyond that, we in the research that I do, we often look at the outcomes across deployment settings. So especially where the context may shift a little bit, you want to be able to look at whether or not outcomes are still being met based on this shift in context. A model might be trained to do one thing in one environment, and you place it into a different environment, and it completely starts screwing up because the context has changed. A very simple example would be I train a model to identify, I guess, objects within images related to, I'm just going to pick up something random here, people. I'm looking for people within images or people within a crowd. And then I take the same model and I bring it to a medical domain. And I wanted to now start taking a look at x rays and identifying regions within the X-ray that might indicate a particular illness or something. We can fine-tune models to do things like this. But because the context has shifted, you have to have some pretty nice, robust testing mechanisms to ensure that you're still meeting similar outcomes across the various demographics represented with that context shift. And if you just plop a model in there, do some fine tuning, and just say you're good to go without doing these checks, no, you're setting yourself up for failure. It's something that's really, really important. Um, we also use demographic parity audits. This is really, really important. And this is post deployment. So once we put something out there, does the model perform the same across all the demographics represented within the users of that model? We have to check for these things. We build in quality feedback, user feedback loops. And this could be as really simple as right now you use Claude or ChatGPT to have the thumbs up, thumbs down ratings when it gives a response. That's feedback. So whether or not you know it, every time you say, nope, that really sucks, or this was really great, you're giving the model and the developers behind the model confidence that a particular tuning that they have done is either working or it's not working. So that's a really important thing to include user feedback loops. Also, we do scenario-based testing to assess like how models behave in like intersectional or ambiguous, cases. But I guess importantly, we found that fairness is often better captured through like user impact than technical performance. Yeah, people like to tout F1 scores, and that's fine. But a lot of times you want to see, well, what impact is this thing having on users? And that's my metric for success. You find that actually now, if you look at benchmarks, a lot of the AI models are saturating benchmarks because they're really, really good at taking tests.
Yeah.
I guess I can put it that way. There are reasons for it. You might say that some of these tests are cropping up within the training data, so they're just memorizing them. But for whatever reason, either the models are getting really just good in general, or they really get good at taking a test. And because it's saturated, you're just thinking, oh wow, these models are 100% accurate at some, math test. It must be like a PhD level genius. But then you put it in a practical, real situation, something that is important to like a user, and it may fall apart.
Like math homework.
Yes. Well, so there you go. It's not that simple, looking at these metrics and just saying, yep, the data tells me my accuracy is good, I'm good. You have to have other approaches to try and assess fairness and impact.
So when you have conversations or provide testimony to state government, federal government, where are the obvious policy gaps that you're seeing when interacting with legislatures or even your counterparts in the private sector? Where's the low-hanging fruit when we're trying to address these disparities between the capabilities that these systems are rapidly acquiring and the protections that individuals and groups will likely need?
Yeah. I think the most urgent gap is it's not so much the absence of regulation, even though that is what people tend to speak to very a lot, which is we need more regulation, we need more regulation. I guess it depends. If you're a company, you're saying, no, we need less regulation. But I think it is the absence of the infrastructure to support good regulation in particular. Right now, agencies are understaffed, and we have budget cuts left and right. We will not speak about what's happening in the federal government just in terms of funding and budgets, but agencies don't have the technical staff to do some of this work. They don't have the data access to do some of this work. Sometimes they don't even have the tools to evaluate AI claims that companies are making in any kind of meaningful way. And companies will they make a lot of promises as to what their AI systems are able to do. And a lot of times, all regulators can do is trust them because AI is changing so quickly. There are no standard methods for them to be able to make a claim and for us to be able to validate those claims. So lawmakers, I think, they should prioritize funding public interest research, establishing standards for things like transparency and auditability, and creating data sharing agreements that respect privacy. Now, why do I say public interest research? Institutions like Morgan State University, but other research institutions as well would have will not necessarily be doing work on the best interest of corporate America. They'll be doing research on the best interest of the public or just truth seeking. Academics typically have a bent towards just trying to elucidate the truth and at least serve the public in ways that are meaningful versus internal research being done by a corporation. So I think they should leverage those kind of ties they have with these research institutions. Um, I think the greater risk, if you think about it, kind of lies in the compounding inequity or compounding inequality through inaction. Because things change so quickly, it's easy to throw up your hands and just say, well, we'll let the industry regulate itself, or we'll wait till everything settles, and then we'll come in there and try and come up with some good legislation. But if you do that, it's going to be too late. You cannot have inaction because what will happen is that whatever inequalities exist right now will just simply compound when the technology gets ahead of where we currently are. And while there are some overt harms like surveillance or discriminatory decisions that are being made, or maybe like credit filings and so forth, those are all very serious and must be addressed. But there is a silent erosion of access. I like to put it that way. This is where communities are excluded from the benefits of AI. And and why this might be, it might be because of lack of access through technology. It might be other forces that essentially exclude a group of individuals or communities from engaging in this revolution that's currently happening right now. And if that happens, there are going to be some long lasting effects, much more than what we perceive, I think. So, fairness in AI just basically means fair access, in my opinion. Fair access and fair treatment.
I'm curious if you would say a little bit more with what you were referring to at the end, because in many cases, these services are currently free, at least when we're talking about LLMs. Like, if you pay for the services, they're certainly better. But in an attempt to gain market share and to uh, gather financial backers, a lot of these services, when competing with one another, will just offer really robust capabilities to any user who has an internet connection. Um, so, given that, how do you understand this question of access?
That this is it's an interesting one. I would say that companies have um, they have provided this perspective or impression maybe that, oh, we're putting everything out there for free and so everyone can have access to it. We're very altruistic. Look, we're just doing great things. Sure, but they're also getting something for it. They're getting your data. And let's be
Yeah.
honest, right?
Oh, I never said they were altruistic. I just said they were offering a service.
So they're putting their tools out there as freely as possible so they can gather your data through interaction and train on it and so forth. If your only method of interacting with these models is through the free plans, there are two things. One, are you really educated on what you're giving up as you're using these models?
Mm,
Okay. And whatever you give up, no, it's in terms of privacy, essentially you have none, right? You're giving them information that's stored on their servers being used to train their models. You're giving up a bit of ownership and privacy over there. Also, it some access may not be enough access depending on your use case. There are many cases now, if you're trying to use VO3 as an example, you're building
hmm
a business, you're running your YouTube channel or whatever, you generate your first two videos. Oh, it looks great. Everything is great. And then you do your third one and you're out of credits and you gotta wait 24 hours, 48 hours. I don't really know. But the thing is, yeah, you have some access, but do you have enough access to make an impact on the things that you're trying to accomplish? If you're building a business off of these free tools because you don't have any money, because you're starting off a business, most likely you're not going to get very far, right? I don't want to make it seem like, oh, it's horrible that they're giving people free access and just limiting just a few, however many tokens or whatever to get the work that you have to get done. They're still a business. They have to operate a business. This stuff costs money. What I'm saying is, as a society, we should think about the fact that if there are a group of people that have the capability to pay the $20 a month or whatever it is to get a premium service, and they can leverage that premium service to do things to accelerate their cognitive output and what they can do with that cognitive output, building a business, doing whatever, those people have a better chance of success. Let's just put it that way, than those who may not have that access. Now, can something be done as a society just to make sure that, at the very least, we protect individuals' privacy, no matter whether or not you're using a free service or not? There's some basic fundamental things that, companies cannot exploit you. And then also, can we provide the mechanism or infrastructure in place to make sure everybody has sufficient access for it to make an impact in their lives and for them not to feel left behind?
So intelligence as a commodity has a compounding effect on personal wealth,
Yes,
you would say. Yeah.
absolutely.
Well, at this point, I do want to ask you a little bit more about the wheelchair system that our teams have collaborated on. And as I make this pivot here, I just want to remind our attendees that we do have a Q&A function that we will make use of at the end of the program. So please feel free to use it at any time throughout the duration of our talk here. Um, so Kofi, you your team at Seamless and our team over here at the National Transportation Center cooperated on the Urban Flow Autonomous Wheelchair System. I would
Mhm.
love for you, as the lead technical designer on the project, to describe how the wheelchair works from the user's perspective. When that person arrives to the airport, what does it look like when they're arriving at the airport entrance and ultimately getting to the plane that they will be traveling on?
All right. Now, we have put a lot of thought into urban flow, so I'm really,
Mm,
really proud that it's at the stage that it's currently in right now. And I think the way we envision the user experience is one where it's easily accessible, it's easy to understand how the service works. You show up at the airport, and this could be a situation where you're being dropped off, and you need some assistance to get to ticketing and to get to the gate. You may be able to control a wheelchair, but you may not also be able to control the wheelchair. Whoever you are, whatever the reason is for you needing assistance, you get to the airport at the curbside. There's a sign or a kiosk available to you or whomever is assisting you to transition out of your vehicle. You scan the QR code there, it launches the app, and now with the app, you can simply request where you're trying to go. So, in essence, if you know that, oh, I'm trying to get to gate A18, you could just say, I'm trying to get to gate A18. But if you don't know, you just want to go and, press check in, which, by the way, no matter what, it's going to take you to check in. If if you want to go check in, you can just say, I'm checking in into British Airways, and it will take you through the door. So it's like starting out on the outside. It will take you through the automated doors, and then you go into a special dedicated line for autonomous wheelchairs. And if there's a queue, it will wait behind the next autonomous wheelchair, or the next person if it happens to be integrated with people in that line, and take you up to a designated point where you can interact with the ticketing agent. Once you get your ticket, you can scan your ticket with the phone, and then it will extract from that the gate that you need to go to, or you can specify on the app, I'm trying to get to gate A18. And then it will intelligently route you. This is through people walking this way and that way. You know how chaotic the airport is. It will route you through all of that into a dedicated line in TSA, so that now you would be automatically shepherded up to the security line, well, the security agent at TSA. Now, at this point, we don't want the wheelchair just going on his own, because there's some protocols in place for TSA, and we want to respect that, and it's respected in the design of the system. So a TSA agent now has full control of the wheelchair to do a process that they're already doing. We're not changing their process whatsoever. Secure the wheelchair, secure the passenger, get them through, finish the scan and so forth. And once they pass the TSA checkpoint, the system just continues on its way once you indicate that you're ready to go. So let's just say you're on your way and you decide, like, oh man, I really forgot to use the bathroom. I have to use the bathroom before I get to the gate. You tell the app, I need to stop at the bathroom. It can either point you to the closest bathroom, or you can pick exactly where you want to go. So maybe it's at the food court, not the bathroom, wherever. And now it will change its route dynamically to take you to the bathroom food court. And then at this point, so depending on your need for assistance, you could request assistance of a human operator or a human individual to help facilitate you doing the next part of things. But if you're able to do it yourself, you can even grab manual control of the wheelchair and simply move it to some designated location. If you're going to be in line or something at the food court, you can technically do this stuff. And then when all that is done, say I'm ready to resume back to my gate or continue on to my gate, and the system will continue routing you to the gate. So in this way, it's super simple. It is designed to be one that can operate with traditional um, uh, operations within the airport, like with TSA. It's designed to work with a human operator or human helpers so that you can basically talk to somebody who is coordinating everything and request help if you need some help. It's just designed to be one that allows you to have both the flexibility of autonomy, but still practically integrating into current systems and processes the way that they work.
Absolutely. Super easy from the user's perspective, but as the technical lead, you can certainly attest that integrating all these systems posed a significant set of challenges, especially, and this harkens back to our earlier part of the conversation, um, how training in a laboratory doesn't always translate to results in an environment, a different environment, or just in the real
Yeah.
world more broadly. So when you're integrating the software and the app, the computer vision systems, the mechanical systems within the wheelchair. What were the major challenges that you faced in integrating these systems so that they were effective for users at the airport?
Well, a ton. There were a ton of considerations to be made. And part of the engineering process is always looking at your constraints, right? Given unlimited funding, you can accomplish a lot of different things, right? But if you are designing towards particular constraints, cost being one of them, that was a big factor, then you have to make certain decisions and trade-offs. Now, the reason why cost was one of the first design constraints is we want a system that is accessible to a broad swath of the population. If you design a system that costs $20,000, right, only a few people will be able to benefit from this technology, right? So we cost it to be very, very reasonable, which means that we had to decide, well, what kind of processing should be on this system? How will it affect the power consumption on the wheelchair? We will not design one from scratch that requires a custom build. We'll retrofit an existing wheelchair. But what does it take to retrofit an existing wheelchair and connect into the control systems and be able to get your sensors integrated properly? Those are all like design constraints that we really had to kind of engineer around. And then there is the issue of what works perfectly in the clean room, in the lab, in the School of Engineering. Once you take it out there to BWI and you start seeing things are not quite the same way as in your lab, it hits you in the face that you have to redesign some things. So an excellent example is the way the system functions. It functions in two primary modes. There is a constrained mode where it's following essentially what is a track, and the unconstrained mode where it can basically move freely about the whole airport. The purpose of the constrained mode is when you're in very tight locations, when you want very reliable behavior, you want to constrain the movement of the wheelchair. The method of constraint was essentially computer vision. There is a track, we have a camera system, we have some process to separate the track from the background, and then be able to use that to serve as a guide. It was originally built on a very classical computer vision pipeline, and we found that it fell apart fairly quickly when we went into environments when we had very bright sunlight, which is casting harsh shadows across the track, or we are in environments where there are some unique patterns on the carpet that is confusing the computer vision pipeline. So we ended up having to create a process of collecting autonomously training data. And then from that training data, we had a deep learning model that learned to best understand what a track looks like in a whole bunch of different environments. And now it's rock solid. So it doesn't really matter what environment you're in, it's pulling out the track and the guide very consistently. The other thing, another constraint is, well, not constraint, another challenge to engineer around was interaction with both pedestrians and just obstacles. There are some well-known methods of doing routing that involves obstacle avoidance and kind of pedestrian, not avoidance, but you're trying to weave in and move with pedestrians. So it's about a prediction of what they're trying to do and so forth. Those methods work well on paper and in some of the publications, but also they tend to require some really beefy hardware to operate at a fast enough rate for it to control the wheelchair. So if you have more modern hardware that you're working with because of a cost constraint that we mentioned before, you have to come up with other methods of attaining the same output or the same performance or behavior. And we're able to do that. So we have our own custom process for trying to determine what is an obstacle and what is the best method to avoid the obstacle or just stop altogether because you can't avoid it in the first place, which translates very well to people and maybe not so much always predicting their precise behavior, but using enough information about what is going on in the environment to be able to just stay in flow with pedestrians. So that's a thing that we're doing as well. So yeah, it's just been super challenging, but also very rewarding to see how everything came together.
Absolutely. So I'm kind of picking up on themes of reaching for efficiency within constraints and also optimizing computer vision systems. And that seems to be a bit of a through line throughout your drive to apply artificial intelligence systems to transportation more broadly.
And I
So,
could
yeah.
say, if I could, it's about using, I'll use AI because that's typically the terminology that is a catch-all for everything now for machine
Mhm.
learning. Using AI in a way that is most useful without infringing on privacy and those and things that I don't think we'd be paying enough attention to. For example, we have a camera system that does look out at the environment to help do things like verify that you are who you are when you're scanning your phone or your TSA and so forth. And we're currently experimenting with using it for a more robust collision avoidance. But because it's a camera system, there's an opportunity for it to collect a bunch of information on just people walking back and forth because it sees everything. And so we have to design the system very carefully that it's employing AI in such a way that it's extracting just what it needs from the raw vision that comes through and not storing anything else, not transmitting it to any other place, not doing anything else with it. It's just enough information to guide it, and that's pretty much it. And sometimes I think um, engineers or companies just over engineer systems, store data that they don't really need to store with the premise of, well, I may need it someday, or this could be useful in some other context, or I don't really know what's gonna work, so let me just get everything. And that's not how we operate. It's not the best way to operate.
Absolutely. So when zooming out and looking at your research program more broadly, how do you apply these principles outside of the wheelchair, whether that's in optimizing computer vision systems and securing users' privacy, which we touched on a bit already, or even just optimizing for efficiency within constraints. What are like some of the low-hanging fruit with respect to transportation systems that you're seeing over the next maybe 5 or 10 years, maybe for optimizing traffic flow, but even like improving transit systems or something like that?
Yeah. Well, really, there's some very clear opportunities, and I think it mainly exists in retrofitting existing infrastructure. I don't think people give enough credit to the whole idea of retrofits because it controls costs and it allows you to implement and deploy quickly without demanding that you're swapping out essentially all your hardware and the infrastructure that supports the hardware. So if I look at existing infrastructure, it could be traffic cameras and public transit stops, right? There is a tremendous opportunity to use existing traffic cameras as very rich sensors, rich in the sense of the amount of information that they can pull out, and you can act on that information. So computer vision can provide things like anonymized mobility insights. So not trying to collect everybody's IDs by facial scanning them and storing where they're going, but you can just get broad insights as to what's happening with pedestrians, with people. For example, it can inform you about curb usage, right? Or pedestrian priority zones, or dynamic routing, bus routing. There's so many things can be obtained just by processing this vision data that's currently either being collected or is currently accessible with hardware that's out there right now. But we need to kind of move beyond, um, let me see, congestion metrics and focus maybe on like mobility equity. If I think of the transportation area, and this is not my area, by the way, I'm an electrical computer engineer, not a transportation engineer. So I may say some things that may be out of pocket here. But in my opinion, if we're moving towards mobility equity, it's about um, designing systems that capture how different populations, like seniors, disabled users, shift workers, how they move through the city. So you have like a holistic mobility being about improving the quality of access, not just the efficiency of movement. Which means like integrating data across like different kinds of modes, walking, cycling, public transit, and understanding like the whole mobility as an ecosystem. I don't know if I kind of answered your question there. I was going all over the place, but hopefully I did.
Oh, certainly, certainly. Um, so when you look at the sort of the totality of these systems, both systems like the urban flow autonomous wheelchair that is serving a very high need community, or the LLMs that we've talked about, which are kind of wrapped up in these broader financial and political systems, even geopolitical systems, with respect to our competition with China. Are you an optimist about how the next couple of years are going to, or not even the next couple of years, the next couple of decades, about how these systems are going to be integrated into society more broadly? Like you being at the forefront of a relatively niche group within the sector, focused on ensuring that the benefits of these systems will be broad-based
Mhm.
and the harms will be mitigated. Um, where do you think we are in that fight?
I am very cautiously optimistic. I think by my very nature, I'm an optimistic person. So I always like looking at the possibilities that technology could bring, the impact it could have on people's lives. And really, sometimes technology is almost a great equalizer. What could have taken a $1 million company with hundreds of thousands of employees to do? One person can do it with AI, which is a tremendous thing to think about. What can that one person build that they could not have built before the age of AI, right? So I am incredibly optimistic about how these technologies can impact people. But if you're asking me what keeps me up at night, so to speak, it is that AI is becoming invisible. It is becoming embedded in systems that people don't even realize are mediated by algorithms. And so you're saying, well, what does that mean? Well, it means that if you have an algorithm, AI or not, that is controlling decisions that you're making, but you're not really aware that it's controlling decisions that you're making, and those algorithms haven't been designed in a way to ensure that it works equally well across all sorts of demographics and situations. It could be that you're being exposed to some inequities that are being exacerbated by the technology. You're not moving at human scale anymore in terms of inequities. You're moving at the scale of technology, which is it's several orders of magnitude higher. So like this invisible risk is so this invisibility kind of creates a risk of unaccountable decision making. So now, who do we hold responsible when the technology does something untowards, if you can even detect it, because it could be in a matter that you may not even know is doing something wrong. But even if you can find it out, like who is responsible? Is it the guys who programmed the system? Is it the company that put it in place? Is it maybe some other mediating agent that is handling your data? I don't know. Like it gets kind of interesting. But anyway, but what gives me hope is that there's growing awareness of the fact that technology and AI as a whole is being embedded like everywhere, especially with young people. I think they're getting much more savvy about it. Um, this actually kind of reminds me about this whole thing about AI generated content. And I see all these videos about how to teach your grandparents that this is AI. So at least I know the younger folks are very much aware of what AI is capable of, and they're more skeptical now when it comes to things that just don't seem right. So that's good. Uh, I also see that students who I see students asking the right questions. If I just think about our Summer AI Research Institute that we just did, we had some great conversations about the impact of AI, and they're just really engaged. They're trying to figure out, well, really, how do I really know that the way I'm using AI in this particular manner is the best way? Is it going to give me factual information? Is it going to screw up and then that will cause some other thing to go wrong? So that's really encouraging. Um, I, I like the fact that people are pushing more for transparency. That's a big one for me.
Mm.
Transparency and explainability. So these are all good signs that we will integrate the capabilities of AI in our society in a responsible way, keeping an eye out for all the things that AI could get wrong and how we as a society can deal with it. But it does take active engagement, though. This is not one of those technologies where you just sit back and just hope for the best. It has to be guided all the way through.
Absolutely. And there's so much I could say till that. You laid out some very interesting pieces about what the next few years look like. But at least when we're talking about um, the intersection of artificial intelligence and transportation technologies with respect to liability, which I think is a microcosm for liability for AI systems more broadly. I think an interesting space to look at is insurance
Yo,
with autonomous vehicles. I think a lot of those early battles will be decided there as far as who pays, who's responsible, and who benefits as a result of that.
absolutely.
Um, but always my final question is when you are looking at all those young people who you just described, those who are becoming increasingly savvy with these new systems, those who are trying to perhaps warn or prepare the older generations in their life about their use cases, what are you telling them about um, the best ways to navigate a world that is changing very quickly,
Mm.
such that they can have the maximum impact or just live a fulfilled life as a researcher, a scholar, and a lifelong student? What advice do you give to the young learners in your life?
I say they should stay curious. Number one, this stuff is like you mentioned, moving incredibly quickly. It's accelerating all the time. But if you are not just learning the tools, which you should learn them, but you're learning to ask questions, like you're learning to ask the why, the for whom, the at what cost. That's a very good place to be. Don't assume that just because the technology is being purported to do X, Y, and Z, that's as deep as it goes. You have to be able to dig deeper and just think, when is the best time to apply it? Is this the right technology to apply? Whom am I applying it for, and what effect will it have? Right? Safe and effective AI, to me, I think it just requires people who can translate between the disciplines, people who understand the math, but also the ethics and the policy and the human experience. I don't want people to think that their voice doesn't matter because they don't come from a CS background when it comes to AI. No, human experience is incredibly useful to guide the future of technology and to make sure it serves mankind appropriately. So bring your lived experience into this area and don't be afraid to dig deep and apply it. Build, and at that core, if you're building diverse teams of people from different backgrounds, different experiences, different demographics, and so forth, then we are kind of building resiliency in how we handle technology going forward because we don't have those blind spots that we tend to have when we have non-diverse teams of individuals working on things. So I'm a really big proponent, and this is like a big tent. Everybody come in and pitch into the development of our own future here, technologically speaking. Um, I think we need to seek out perspectives, or they need to seek out perspectives, we all do, that challenge our own assumptions. Whatever your assumptions are, try and find some dissenting opinion to challenge it to make sure that your assumptions can stand, can kind of stand even under critical thinking or criticism, rather. And don't wait for permission. And I think most times, many many of us, right? We do not. How can I play this? I think many of the most important innovations in what we call responsible AI have come from students and early career researchers, people who just didn't think that they necessarily had what was needed to contribute to this area, but they did. So don't wait for permission to explore things, to just, I don't know, try different things. You'd be surprised. Yeah. And just have more agency. Be your own person. Be an independent thinker. There you
Hmm.
go.
Stay curious, be involved, keep asking questions. The 21st century is going to be pretty weird, so I think we need all the help we can get.
It's gonna be fun though. I think it's gonna be fun. And we just have to make sure it's safe and fun and fair.
Certainly. All right, Dr. Kofi Nyarko is the director of DEPA and Seamless and a professor at Morgan State University. I am so happy I could have the chance to discuss these really interesting topics with him today. So thank you very much, Dr. Kofi Nyarko. And we hope we see you again, maybe on some other episode of Transportation Talks.
Thank you for having me. It was a lot of fun.